This is Greg Pasternak from Riverside Life. Today I'm in the south central coast region of California, continuing my field trip here. You can see I'm getting a little bit more grizzly as the trip goes on. I'm in a very different kind of channel today, and this is going to be a pretty interesting comparison. So today I'm east of San Ardo, California, in Pancho Rico Valley and Pancho Rico Creek. There's a lot of things to talk about with this creek, but let's just start with the basics of the classification. Now I want to point out I'm not exactly at this measurement site. The measurement site is very close to where this valley terminates down in the Salinas Valley, and I don't have permission to go onto those private lands the way that the field crews worked that out. But that's okay. I think still the overall context of the valley is good. So I think one key thing is it may be that right near the mouth there where the measurement was, that the valley comes out as an unconfined valley, but it's definitely not an unconfined valley for the vast majority of the length of it. It may not even be down near the site. And so what you can see about Pancho Rico Valley is there's an awful lot of terraces that are here. There's also, in this case, a very good channel floodplain connectivity, and there are walls. So I'm going to spin this around so we can take a look at what's going on in the valley context. So as you come around here, you can see the very steep valley wall on the side, and now we're looking in the downstream direction, and you can see sort of all along the left side there that, you know, we have that confinement. On the right side, you can see my car there is up on the terrace level. So there's a terrace level that the road is on, and it goes higher, and then there's higher terraces and hillsides off on the right side of the valley compared to the left side. So the valley confinement here is important to the overall freedom of the channel to be able to move around, and in this case the channel does have a lot of that freedom, but I wouldn't call it unconfined for most of this area. If we look across, you can see that there is a very nice connectivity here between the channel and the floodplain. So, where I'm standing right now, I'm on a floodplain level, and you look across and you can see the floodplain there as well. So a floodplain is defined as a flat depositional surface adjacent to the channel. Here we have very clear channel geometric dimensions, and then we can look at the base flow channel. So let's talk about the classifications for this stream. It is classifying as a California statewide type 3, which is unconfined gravel pool riffle. And then for the regional classification, it's also unconfined, again because the site farther downstream, unconfined high order sand gravel uniform. So there's some significant difference in those classifications, and I think this is a site where the statewide classification just really isn't doing it justice, where the regional classification has a lot more value. And why? Because you look here, you can see, yes, the sand gravel component, there is some cobble that's in the stream, but you can see predominantly sand on the surface and fine sediment being silt and clay. But a lot of sand and some gravel. We can also look at the fact that the undulations, the bed undulations here, even mathematically at the site, are very, very low. So that bed undulation it's a low, very low compared to most other sites, and really is too low to be classified as a pool riffle. On the other hand, the width undulations in this are high, but I also just really again want to emphasize the high channel floodplain connectivity. So I think another thing that's really important to talk about with this site is the comparison of this site, Pancho Rico Creek, versus San Luis Obispo Creek, the downstream site. And if you haven't watched that video, I encourage you to pause and watch that video because it's a really important comparison. So both Pancho Rico Creek and San Luis Obispo Creek in the downstream site are both classified as the same type, which is this regional type 1, the unconfined sand gravel uniform bed channels. Yet, as you can see, the number one huge difference between the two is that this site here on Pancho Rico Creek is unentrenched. There's no entrenchment here, and in San Luis Obispo Creek, it was highly entrenched. However, both sites have the same attribute of high width undulation variability with very low bed undulation variability. So even though San Luis Obispo Creek was entrenched, it still managed to have a moderate width variability, and here we have that anyway. So it's interesting that both of those rivers are able to adjust in that regard, even with the entrenchment that's going on. I don't know if that's unique to San Luis Obispo Creek being in the entrenched setting that it's in or not. Pancho Rico Creek has twice the catchment area roughly compared to San Luis Obispo Creek, so it's definitely going to be a bigger stream. But I think it's really important to think about how good the channel floodplain connectivity is here. And what that means is that when the river floods, instead of the water being limited to just staying within the channel, it can get out onto the floodplain and dissipate the energy, so we're not incising more. So, once a system becomes entrenched, it tends to just keep entrenching, because there's nowhere for the water to get out. So larger and larger floods are carried by the channel. Out here, there's plenty of room for the water to spread out. Okay, so that gives you the basics of the classification of Pancho Rico Creek. We have now seen two examples of the South Central Coast Type 1 channel, this unconfined to what, here, at least where I'm standing, partially confined, high order, sand, gravel, uniform channel, and the fact that in these systems, even though the bed isn't undulating, if you have enough space, or the entrenchment isn't too limiting, you can get some really good width undulation.